this should work. Okay, so everything that you need for today you can find on my website. If you click on our tutorials, this link here, scripts for source, will give you a link into all the files on my computer. So if you click it, hopefully this will load. And you can find today's script under today's date and multi-panel plots. So every time I hit save, this will update, and you can find everything there if you can't see it on the screen. Also, you'll need a data set. It was the same as last week, so if you have it from last week, it's the same one, but simulated data 01.csv is what we're going to be using, so make sure you download that. And so let's quickly review what we did last time, which is what did we do last time? We imported a data set and then we plotted it, right? And so what are the steps that we need to do to import this data set and plot it? Yeah, all right, so we do that. Set working directory. Mine just happens to be under this path. Source, fall, that. Okay. And so once we do that, again, I like to do list.files over in the console, just to make sure that the file that we're looking for is there. And it is. There's simulated data 01.csv, which is what we want. And so we need to read it in. And so the command is read CSV. Today's the 24th, yeah. Simulated 01.csv. All right, so you run that, and you can see that it punches it out to the console. So what we'd like to do is save it under something called my data. And then in order to plot it, we need an X, we need a Y. And in this case, our X will be the X column of our my data, right? So how do we get that? Yeah.
Square bracket.
Column 1. Yeah. So actually, why don't we mix it up? To get the Y column, you could also put $y, but if you wanted to, you could say, I want all the rows of the second column. Same thing. So we plot it. This is our data set. I want to quickly go over the things that we're going to go over today. So first of all, eventually what we're going to want to do is make a multi-panel plot, which is neat. But I think in order to make a multi-panel plot look nice, you also have to make a single panel plot look nice. You have to be able to change its aesthetics. And for example, if you just look at what our plots out, in terms of this plot, there are a couple things that could be changed. First of all, these axes, right? You might want to give them a custom name for your X and your Y. The other thing too that really bugs me about basic plotting in R are the margins. So if you look, there's a lot of dead white space all around here. And you'll soon see that if we don't correct for that and in the multi-panel plot, there will be, if we put two plots next to each other, there will be twice as much dead space basically. So we need to learn how to be able to get rid of this dead space. And finally, how to put it all together in a way that makes sense. All right, so in terms of manipulating axes, there are a couple things that we can do. For example, one of the things I mentioned was to change the X and the Y. You can change those very easily with XLab and YLab, and those are for X label, Y label. And so, for example, if we just wanted it to say X instead of my data $X, we could do that. If we just wanted it to say Y, we can do that. And when we run it, we see that we've updated it to X and Y. Another trick that might be handy is, what if you want no values, right? What if you just want a blank space, no X and no Y? I just copied and pasted the command, and you can just get rid of the X and have a double quotation mark, and get rid of the Y and have a double quotation mark. So now when you plot that, you see that the X and the Y label have gone away. Other things that you might want to do, for example, if you're generating, say, a hypothetical plot where your x-axis and your y-axis don't matter, you might want to exclude the axes and the tick marks altogether. Again, like for a hypothetical figure where you just show that there's a line or there's a curve, you might, it's because these numbers don't actually mean anything, you might want to get rid of them. And the way to do that, I'm just copying and pasting again. Let me actually copy and paste that line. What you can do is add these arguments that are xaxt, and if you set that equal to a quotation mark n, you're basically saying for the x-axis, tick marks are no, right? So that's what this xaxt means. X-axis, tick marks. If you set it to an n, it'll get rid of all of these. So when we run it, you see that all of those went away. But suppose that you still wanted the X label, you wanted something down here to say what it was. Maybe you can just put the X back in and you'll see it. So now here's the really annoying thing I think about this, which is that even though you've specified that you want no X tick marks, there's still all that blank and empty dead space, right? So this looks very awkward. This is something that you might export out into like Inkscape or into like, what's the Adobe one? Illustrator. You might just like export this out and fix it there. But I want to show you ways that you can fix at least some of these simple problems in here. And so one way that you can do it actually is to not plot this X out there, right? So we leave it blank, and there's a function that you can add that basically adds in a title, adds in an x-axis or a y-axis, and that function is called title. Now, title doesn't generate a plot all on its own. It'll add something to an existing plot, and if you hit tab, you'll see all the different things that you can put in here. So if we wanted to put in a main title, we could. You'll notice that we have no name for this plot right now, but if we include this, we can get a title right up top. So let's go back to the x-axis thing. I'm just going to copy and paste these again. So I'm going to run this line of code to get no x-axis and no labels. And instead of having a main here in title, you can put an xlab, right? So that stands for x label. And here we can put in x. So this is just another way that you can add in labels after the fact. But another thing that you can also add in here is something called line, and that's the distance in lines that this label will show up from where it's supposed to. So this is supposed to show, since it's an X label, it'll show up somewhere here on the bottom of the plot. And this line is set to default something like 5 lines. So it'll put the X 5 lines below this boundary right here. But if we just say, let's just make it half a line, if we do that, now we see that that x-axis is half a line below where it should be. Right, so that's the easy way that you can control where this happens. And if you want a little bit more space, right, if maybe you wanted 1.5, you'd have to reset the plot. And the only way to reset the plot is to plot it again. That gets rid of that x, and now we can change this to maybe 1.5 and see how that looks like. So what I was always confused with in terms of editing these plots to make them look the way they want was that I never actually found a list. Until recently, I haven't found a list of like all the arguments that can go in, right? Because if you do plot, you'll see that it's just a triple ellipse or an ellipse, right? And there's, you can scroll down and you can see some things that you can put in, but this is not the entire list. If you want to see what you can do, this might not even be an extensive list either, but it gives you a whole bunch of things, which is this. If you look at the documentation for PAR, P-A-R. So if you question mark that, you can see all the things that you can change. So for example, ADJ, the value of ADJ determines the way in which text strings are justified. So ADJ for adjustment, right? You can change how things are justified. You could change the background color of your plots with this BG. Some of the more typical ones are CEX. So CEX changes the size of the characters that you plot. Color, we've already seen that, COL. Color main, color sub, all these. But the one that, so you can look through this and see the different options that you can use for plotting. The one that I want to call to your attention right now is margin, MAR. And the reason why is because although our plot is almost ready for multi-frame, you'll see that, well, let's get rid of this. Let me run this again. So you'll see that x-axis is kind of where we want it to be, right? There's very minimal space in there. We've gotten rid of our X tick marks. But you'll notice that there's a lot of blank space up on the top, a blank space up on the bottom, and left and right. So the way that you control that is with the margins parameter. So here's margins and MAR, and I'm going to read it. So it's a numerical vector of the form bottom, left, top, right. This is really important to memorize. In fact, I'm even going to make a comment here saying that margins is bottom, left, top, right, just so I don't forget. And it's also really handy. It also shows you what the default margins are. So the bottom is 5, the left is 4, the top is 4, and the right is 2, all plus a 0.1. And these are all measured in lines, right? So it's saying that the very bottom margin of the plot is 5 lines below the x-axis. So if we want to start messing with it, one of the first things that we might want to do is start cutting out some of this bottom space. And so that bottom space is that first number. And the way that you do this, I think you can stick it into the plot function, but I actually like running it ahead of time. And you can do that with the par function. And we can do margin is equal to, and let's just keep it the default values for now. What was it? 5, 4, 4, 2? Plus 0.1, but we'll just leave that off for now. So this is the default value. Let's change the bottom from 5 to, I don't know, 2? Let's see what that looks like. So when we run that, nothing actually happens, but what it has done is it's primed your plot window to accept these parameters. So the next time we generate a plot, it'll use these parameters. So again, maybe I'll just type it out from the start. Plot is equal, x is equal to my data $x, y is equal to my data $y. We did x lab is equal, I'll just keep it at x for now. Y lab is equal to y. And xaxt is equal to quotation marks no, to get rid of the tick marks. So now when we plot it, we'll see that we did cut out some of that space. I have to do that thing again, right? Title, x is equal to, xlab is equal to x, and we'll do line is equal to 0.5. There we go. So that looks a little better. This is kind of the annoying part where I mean, in my opinion, it's all just trial and error. You go and you try different values until you get the plot the way that you think it should look like. But for example, I want to cut out some of this space on the top, maybe even some of the space on the right, because the whole goal of this is we're going to combine these two different plots together. We're basically going to split these plots up and then combine them back. And so maybe I want to come back here and I want to change right and top, right? So right and top are the last two. Right is now at 2, so I'll set that at 0, and top, I'll also set that at 0. There's no reason for it not to be. Oh, except for that, which cuts it off a little bit. So that was too much. Let's do 1 and 1. There we go. That's looking better. So we're nearly ready to put these plots together. The last step that we need is to remind ourselves basically how to break this one plot into 2 separate plots, right? We need to break it in order to put it back together. Limit the x-axis on plot. So I am just going to copy and paste these because these aren't going to change. These are exactly the way I want them. What can I do in the plot function now to just say only plot these points over here? Mm-hmm. So I think this is at, yeah, I think right here is at 0.05. We can double check anyway. But the way to do that is you basically limit your axis using xlim. And here, xlim is expecting two numbers. It's expecting the left margin of your x-axis and the right margin of your x-axis. In order to feed two numbers into this thing, we have to use the C function to combine or concatenate. And again, we want to go from 0 to say maybe 0.05. So let's see what that looks like. Yeah, there we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. All our points are here. Oh, and we have to run this line again to get our x. There. And you'll notice that we didn't have to run this par function again, right? That's because once we set par, this is applicable for all plots in this device until we close the device. So you might be asking yourself, how do you close the device? How do you reset this without having to put in the default values back again? And so that is dev off for device off. If you run that, it'll close your plotting window. Oh. And you'll see it'll say null device 1. And if you run it again, you'll see that there's an error because there's no more device that's open. But now if we plot this again, you'll see that our margins are back to the default. And so in order to fix it, we have to run this again. So maybe we don't want this. We have to readjust a bit. All right. And again, this is just trial and error for me. We need to increase the bottom margin, and then we need to move the X label down a bit. So bottom right now we have set at 2. Maybe we'll increase it to 3.5. I don't know. Try it. Okay, I'm actually gonna get rid of that. And now this is too low, so maybe I'll bump it up to 2.5. Maybe that's too much. Let's just do 2. Yeah, that's good. So I'm gonna rerun it again. Let me save that. While we're here, I'm just gonna throw in PCH because that's also a very common one. So that controls your point character. If you set it to 19, you basically get filled in circles, which sometimes is easier to look at. So that's another common one I use, PCH 19. I just throw that into the plot function. So I'm going to get into simple multiplots. This is probably, I want to say maybe 75–80% of all the multiplots you're going to make are going to be the simple variety, where it's a very, you don't need to give a panel different sizes, and you'll always have, basically your panels can fit on the grid. And the way to do this is using another par function. Now we're going to add this, which is mf row. So it's multi, I don't know what the f is, row, to get you different panels. Right now, it's probably the default 1, 1. So 1 row, 1 column. If we want 1 row, 2 columns, we can just change that to 1 and 2. So when we run that, nothing happens. But now I'm just going to copy and paste this back down. Now when I run our plot, you'll see that it takes half the space. And when I come down here, I just copy and paste it. I'm going to do it again, except now I'm going to change the xlim right between 0 and 0. Well, actually, maybe I won't. I'll just do this for now and run it. So now you'll see that when I run the plot function the second time, instead of overwriting the plot that we did, it puts it into the second space that we've reserved for it.
Wow.
So that's the basic way that par_mfrow works. You set up a space giving it a number of rows and columns, and every time you run the plot function, it'll go from left to right, top to bottom, putting the plot in its reserved space instead of overwriting the plot that you just made. So you can see that, well, now I just did the same function over itself, so it's just a replicate, but we could just as easily in the second plot, instead of being xlim from 0 to 0.5, you could say 0.5 to 1. And now when I run the plot again, you'll see that the x dimensions are different, and they're put together on a single plot. And again, just to be clear, these data are from the same data set. They're from the same plot that we generated at the very beginning of the session. Right now, we're just breaking up into we're breaking up the data into different subsets and plotting them on different scales of x-axes. And again, if you want to get rid of this formatting, all you have to do at the end is device off. That'll close the plot, and it'll set everything back to its default value. So now if I go up to the very top and I do this plot again, it's just a single plot. It's not sharing it between two different sides. I'll send this PDF out. There's a really great tutorial PDF that Sean Anderson put out in 2011 about multiplotting.
What's that type of?
Multi. Yeah, it's actually a really, really good read. I'll probably send a link to it in the next email. But this is where I learned about split screen. And just to show you what split screen can do, instead of just having these normal grids that are 4x4, you could make grids that look like that. This is where I got the inspiration to do that plot. You could make really crazy non-uniform looking grids, so this is all one single plot. You can go as crazy as you want with it. Again, it's a little fiddly, it's a little bit of trial and error, but you can do it. So I'll send this out and show you very simply how split screen works. So like par_mfrow, you have to do the same sort of thing where you set up your grid before you start plotting. And the way to do that is I like to say, well, why don't we look at split screen really quick. Split.screen is the function. So if you look at the help menu, you'll see that this figs parameter, it's a 2-element vector or a matrix. If it's a matrix, then each row describes a screen with the values for left, right, bottom, top of the screen in NDC units. So 0 at the left corner and 1 at the upper right corner. So you can read that and try to make sense of it, but basically what we want to do is make a matrix where each row represents every panel that we want to make, and every row is going to have 4 values. The 4 values are going to be representative of the left, right, bottom, and top. I'm going to write that down because that's different from the other one. Left, right, bottom, top. Right, so if you look at par or the margin function, it's bottom, left, top, right. So it's always important. I like writing these as a comment just so you don't forget. So okay, again, to describe this matrix, the matrix will have one row, or it will have a row for every panel you want to create, and it'll have 4 values. Those 4 values will tell you the left margin, the right margin, the bottom margin, and the top margin. And those numbers will be scaled from 0 to 1, so you can think from like 0% to 100%, where 0 is the lower left and 1 is the upper right. So I'll do 0 lower left, 1 upper right. So these are all the notes that we need to make. So I'm just going to say my panels, just make something random. My panels is equal to, so there are different ways to make a matrix. The easiest way to make a matrix, I think, is using the rbind command. It's kind of like the concatenate function, except it glues multiple rows together. So if we have a row of 4 numbers there, and here we have a row of 4 numbers there, this will give us our matrix. Right, so 1 number, 2, 3, 4 numbers there. So again, we're using the concatenate function to make a series of 4 numbers, and we're nesting that within this function that's rbind, which will take these 2 rows and make them into a matrix. If that makes any sense. Save that. Okay, so let's start with the first panel, and again, that first panel will be that smaller, thinner 0 to 0.05 x scaling. So let's start with 0 to the lower left. And now our right margin, so 0.5 would be right in the middle, right? So why don't we change that instead to 0.25? Let's make it half of that. And then the bottom and top margins, we'll say that this goes from 0.05 to 0.95. Just give it a little bit of space. Maybe even this, make it 0.05 to give it a little bit of space. All right, so let's go over these numbers again. This is the margin from the left, so it'll be 5. So our first panel will start 5% from the left. It'll go to 25% on the right, and then these are just the bottom and top, giving us a 5% margin on either side. And so for the right panel, let's start this at, since we ended this at 0.25, let's start it at 0.3, and let's go to 0.95. And again, we'll copy the bottom and top margin to keep them the same, 0.05, 0.95. Right. So at the end of this, when we run it all, we now have created a matrix called myPanels. And this is the information that Splitscreen will use to set up our screen layout. So to set up layout, what we're going to do is we're going to do Splitscreen, split.screen, and figs is equal to myPanels. So you'll notice the first thing it does is it clears everything out. This is a different kind of device plot. This is separate from our usual plot function, but it just clears everything out and it's waiting for our plots. And in order to specify what plots we want to put in, we just say screen, and then we say which one. So this is these numbers are referring to rows. So our first screen will be screen 1, and I want this plot that we made, right, where the xlim is 0 to 0.5. So I'll put that down there, and I'll hit screen 1, and I'll plot. It says the figure margins are too large, because I have to make it bigger. Screen close, screen off, close screen. So I have to reset everything. Let's see if this works. Yes. No, dev-off will work, yeah. So the reason why this is looking funny is because I did not include the margins, right? We did a device off, so all the margins got reset. So I have to make sure to put the margins up here. And start over. Device off. Split the screen. We're going to do screen 1. I'm going to set my margins. I do my plot. And I put a title. So far, so good. And now I'm going to go back up here, and I'm going to just copy and paste it, and I'm going to change this to screen 2. The margins should be exactly the same. The only thing I'm going to change is this xlim here. It's going to be from 0.5 to 1. So now, if I run this, I get that.
So like 1, 2, 3, 4, 5, 6.
So if that happens, what you might need to do is do what I did last time, which was close.screen, and then all screens equals true. That's one of the parameters in there. So you might need to do that. I found sometimes I get errors, like really wonky errors, and running this a couple times helps. So I'll just put that in there. And again, if you're having problems, so I had an issue once with switching screens because I had too many screens open from running creating screens multiple times. If you run this command, close.screen all screens equals true a couple times, that will reset everything. That's like the equivalent for device off for screens. So I mean, this is almost there, and you can see you could mess around with the margins a little bit more. You could get rid of this y-axis, maybe make this y closer to this y-axis using the same functions. But that's basically it. And actually, it was with this, I mean, I would just show it off. Why not? The reason I learned this in the first place was because I was making some animations where I needed to be able to make really custom multi-screen panels. So these are 3 separate plots. And you can see that it's an animation, but it's the same principles. I use split screen to make 3 different screens. I have 3 different plots that are synced going at the same time. But that's the reason why I learned how to do this. And again, you'll see that I blew up these because I made it for a figure. I got rid of the x-axes and y-axes because they didn't really mean anything to me. It was just a demonstration. But this is just another way that you can use these tools to make like really cool looking animations.